Hi, today is 10.5 in Finite Math class. Today we're just going to have a couple just really quick examples here on how do you work with a matrix or a game that is non-strictly determined. You got to recall that up until now we were finding out if a matrix was strictly determined or not, and up until now, yes, they all have been. So what if the game is not strictly determined? So if we look at that, then we need to think about that the players need to mix their strategies, and this is where we get the name mixed strategy games. Now, we have an expected payoff when we have the players mixing their strategies, and that formula that we're going to be using is E is equal to PAQ, where P is going to be the strategy of player 1, and Q is going to be the strategy of player 2. And matrix A will just be the matrix that you've written before in terms of you have to decide which way you're going to do this, but most of the times I will do this in terms of player 1. So that's the formula we're going to be using. E is equal to P times A times Q. A would be, or I'm sorry, P would be a row matrix and Q is going to be a column matrix. So that is all in that box that's on your notes. We're going to go on to the next page. Here we go, example 6. I've got this hopefully written, copied correctly. The matrix A, matrix P, and matrix Q. I'm going to have to pause for a minute. I need to get my calculator. Okay, so obviously my calculator that's here on my computer is having a few issues here. So we'll just have to, I'll just write out what you need to be putting in your calculator. Again, I would not multiply these matrices by hand. I would be putting my matrix P into the calculator. So I have again let me write this formula here. E is equal to PAQ. So I'm going to have then my expected value is going to be my P, which is 1/3, 1/3, 1/3, times my matrix A, which is 3, -1, -2, 1, 1, 0, times my matrix Q, which is 1/3, 2/3. Now I'm going to throw that in my calculator all at one time. So when you think about this, what you're doing is you're putting this, when you type this in your calculator, this under matrix A, and this under matrix B maybe, and this one under matrix C. It really doesn't matter where you put it. Just when you multiply it out on your screen, you take A times B times C. Now, if you're looking at these thinking, I'm not really sure these are going to work, now think about the dimensions. This is a 1/3. This is a 3/2, and this is a 2/1. So those two match up, these two match up, and your answers will be that dimension. So you would get a 1/1 answer. So if you look at your response in your calculator, whoops, when I multiplied these all out together, it would come up with an answer that looks like that, 2/9. Okay? So basically my expected value, my expected payoff I should say, is 2/9, and since it's positive, that means that the game is biased. It's an I in there. Can't see it. B-I-A-S-E-D, in favor of player 1. And it has a payoff of 2/9. Expected payoff would be 2/9. So if it was negative, it would be in favor of player 2, and if it was 0, we would call it a fair game. So there we go, that's example 6. And again, type those matrices into your calculator under like A, B, and C, and on your home screen you just multiply A times B times C. Okay, the next one is example 7. In the children's game called Matching Pennies, each player simultaneously shows one side of a penny, either a head or a tail. If the sides that are shown match, player 1 wins the penny. If the sides that are shown do not match, player 2 wins the penny. Model this game as a two-person zero-sum game and find the expected payoff if each player chooses heads half the time. Okay, so first of all, I'm going to write my matrix A. This is example 7. Matrix A, I'm going to write that in terms of player 1. So I'm going to put, they're both showing heads and tails, and this is for player 1. If they both show heads, then player 1 wins a penny, so that means that they get 1 penny. She gains a penny, or he. Or if they're both tails, player 1 will receive a penny from player 2. But if they don't match, then player 1 has to give up their penny. So that person's going to lose a penny, and we'll give it up to player 2. And the same thing down here, if one is heads, one is tails, then player 1 is going to have to give up their penny, so they're going to lose a penny. So there's my matrix A. Now, it told me that each one of the players is going to choose heads half the time and tails half the time. So that means matrix P, let me go back to making that in black maybe. Now remember, matrix P has to be a row matrix, and matrix Q has to be a column matrix. Now, since they're each picking heads and tails half the time, the probability will be equal, 1/2, 1/2. And then once again, I'm going to use my expected payoff, because that's what I'm trying to find, P, A, Q. So I'm going to, since my calculator is not working, I'm just going to show you the matrices I would be multiplying together. 1/2, 1/2. Matrix A is 1, -1, -1, 1. And matrix Q is 1/2, 1/2. Now if you want to, you can stop the video right now, give everybody a chance to put this in your calculator, and find out what that expected payoff is. So you can stop the video and find out. Give everybody a chance to multiply it out in their calculator. Now again, in your calculator, I would put this in as matrix A. It's a 1 by 2. Put this one in as matrix B. That's a 2 by 2. And put this in as matrix C. And that is a 2 by 1. And then just multiply. On the home screen, you just select matrix A, select matrix B, select matrix C. And you guys can help each other out on how you can use the technology to do that. If you need some help, just don't hesitate to ask somebody in the class. Okay, final answer. Here we go. Final answer that I got, boom, right there. I got 0, which means the expected payoff is 0. Therefore, the game is fair. Okay? So there you go. You've got homework you need to work on, and that's just probably the last lesson I think we're going to do in Chapter 6. So you guys have a good day. Bye. Okay, so maybe I'm not done here. I finally got my calculator here to work on my computer. So this will be for those of you who need help on the matrices and things like that. I'm going to do example 7 on the calculator here. So if I want to input matrix P, second x to the -1, I'm going to go over here to matrix A, but I need to edit that. Now we said that we're going to put matrix P in first, and that is a 1 by 2. So I'm going to type 1 and then a 2, enter. And that is 1/2, so I'm just going to put 0.5, enter 0.5. So there's my matrix P. Then I hit second mode to quit. Then I'm going to hit second x to the -1. And now I'm going to go over here and edit, arrow down to matrix B. And that's where I'm actually going to put in my 2 by 2 player 1 matrix. So hit 2, enter, 2, enter. There I hit 1. negative 1, negative 1, 1. Now there's my second matrix. That's actually my matrix A that's in my formula. Second, x negative 1, now edit. Go down to matrix C, and that is going to be a 2 by 1. So that is going to be a 0.5 and 0.5 again. So I now have all my matrices in. If I want to go back here to see those, I have A, B, and C. Now remember, mine are actually in order: P, then A, then Q. These are the matrices that I use. There's P, there's my A matrix, there's my Q matrix. So on my home screen, I hit second and then mode to go to my home screen. I'm going to select, so I hit second, x to negative 1, so just hit A to select it. Second, x to the negative 1 to get your matrix. Now select B. I do not have to put the multiplication sign in the middle. It's an implied multiplication. Then I go down here to matrix C. A, B, C, multiply together, I get 0. Now these little brackets around here just means it's a matrix. It's a 1 by 1 matrix, and I got 0 for that. So there you go. I don't know what was wrong with this software earlier, but those of you who needed it, there it is. So hopefully that helps. Now I think I'm actually done now. See you later.